Hello, all. This is in a book that I absolutely love, which is called A Beautiful Journey Through Olympiad Geometry. It gives wonderful examples, and what we're going to be working with today is the plethora of problems they have. I'm going to be going through it slowly, one by one. So, let's start with problem one, and let me show you my thought process. While I have probably done this problem before, I have no recollection of this, so I'm going to be doing it completely blind. Okay, let's bring it up here, straighten it out. Here, okay. Now, one thing I always say, draw it out. Makes it so much easier, and you can make some speculations in that case. So, let's see, what does it say? Let C be a point on the line segment AB. Okay, let's draw AB. It's good enough. Let's see A. And this will be B. So C is just a point here. So I think that can be general. So I'm going to put it, you generally don't want to put it in the center or obvious places like that. Just because then those could sometimes lead you to some other conjectures that may not always be true. That's why you want to usually choose just a random arbitrary point. Okay, next. Let D be a point that doesn't lie on AB. There's nothing about it, so I'm just going to draw a random point here, D. Okay. Let M and N be points on the angle bisectors of ACD and BCD. So ACD, BCD. Okay, so whenever I see, like now they're talking about CD a lot, they're doing that connection, so I'm going to just draw the line. Again, just makes it easier usually. So now we're going to be looking at the angle bisectors of those. So I'm going to be drawing that out, just choosing a point here, M. Okay, now this is on the angle bisector. So this equals this. Even though like this may just seem obvious and you don't need to draw it out, it's always useful to have just in case you just on a whim forget. It just makes it easier for everyone. So let's start this angle bisector. Again, I'm going to be denoting it. If you haven't seen these before, this is a good way of denoting that two things are equal, just drawing these kind of lines through them. Is there anything about the points MN actually? So MN is parallel to AB. Okay, let's look at that. This probably around here. That looks kind of parallel. We should probably draw this line. Oh lord, that's horrid. Okay. It is probably going to be a bit easier on paper. Okay, that's fine for now. It doesn't need to be perfect. It just needs to get the point across. Prove that the line CD bisects MN. Okay, there's this point here. And because we're talking about this point here, again, you usually want to try and label everything just so you can always write it out nicely and also explain it well. So I'm just going to name this point E. We've used A, B, C, and D, so let's use E. Okay, now you just want to sit with it for a bit. So I suggest spending a couple minutes just sitting with this and trying to figure it out. Okay, I've looked at it for a bit. And now, I haven't solved it or anything yet. Again, I'm going to show you my whole thought process. But immediately I'm noticing that what we have in here is this, and what we have outside is also this kind of pair. So let's, if we say that like this is alpha, that's some way of doing it using Greek letters. That's a nice way. So if you notice that basically it has each one of the angle bisectors here, each like half of the full angles. This also outside has half of the full angles. So what's inside here is half of this whole angle, which we know is 180. Therefore, I know this angle has to be 90 degrees. So let's just write that out nice and simply. So I don't have the nice angle key, so I'm just going to write ang for now. Angle, what's that? MCN. Sorry. Angle MCN is equal to 90 degrees. There we go. Now what else can we see? Now again, we've drawn it out. Now we want to see what information we have. That's always a good thing. So again, D is an arbitrary point, C is an arbitrary point. There's no information there. Point on the angle bisectors, we've drawn that out nicely. What else have we? Oh yeah, M and N are parallel. Okay, immediately you should know your parallel line theorems. Again, if you don't know them, that book, Beautiful Journey Through Olympiad Geometry, a wonderful option. I immediately noticed since these two are parallel, we can use the opposite angles to say that this is equal to this angle. So we have this here, and the same thing here. This is equal to this angle. Ah, okay, now I see it. Again, now from here, I think next step should be kind of obvious understanding, is you should notice that we have two triangles here that are isosceles. They have two of the same angles. And if you didn't know, isosceles, if they have two of the same angles, that means that these two sides are equal. So I'm just going to use another notation. You usually use a squiggly line. So this is equal to this. And because these two are again isosceles, this is an isosceles triangle, this side is equal to this. And now we see it. These two sides are equal, therefore this and E was the point which did cut through it. Therefore, it split the line in half. There we go. That was a nice, simple problem. And it shows you how you want to make sure to use every single one of the information, draw it out in some way, find a way to use it. We draw out everything, but drawing out parallel lines, not the easiest thing to do. But we could try to use parallel line theorems to draw out something with that, and that's when we were able to find it. And now, actually, I noticed, I have this here. This is another thing that I made, that this angle is 90 degrees, though we didn't actually need that. Now, I can see that there are different ways I can tell right now that it is 90 degrees in other ways, though it's not something that you need in this proof at all. There may be some extra information that you may find, but that may not be needed. But it's always good to try to write everything down so you always have it with you somewhere. Okay, now, last part that I love to do, and I definitely recommend that everyone tries practicing. I also definitely need practice with it, but it's writing proofs out. So, let's do that. Okay, proof. So first, what's one thing that we named? Making sure that you have all the relevant information is good. So we named E. Let's say let E be the intersection of, what is it, CD and MN here. CD and MN. Okay, so now let's talk about what we did first. So we had some other ideas, but the main thing we did first was the 90-degree angle. That's what we added in. So because MN and AB are parallel, we can use opposite angle congruence, saying that these angles are congruent and these angles are congruent, to prove that, sorry for the bad notation, but that's the best I can do, that this angle EMC is equal to this angle here, MCA, angle MCA, and we consider that angle is also equal to MCE, angle MCE. Now here, one thing I actually want you to notice, when I wrote angle EMC, I could have also done NMC, that's the same thing. But in the end, we are using this triangle, right? We're using these two separate triangles. So usually you want to use the kind of terms which incorporate those two triangles. Okay, anyway, let's go back to this. So, say this is equal to this, and therefore in the end, these two are equal. We're going to say the same thing for this triangle. So, we can use that to prove that this is all true, and angle ENC is equal to angle NCB, which is equal to angle NCE. Okay, so yet again, we're just showing that these two are in the end equal. So, I mean, overall, if you didn't get the full gist of it, we're saying this is equal to this, and this is equal to this. So therefore, by looking at the whole equation, we can see that this is equal to this. Just using parallel lines and then angle bisectors. So, because the triangles MCE and NCE both have two congruent angles, they are both isosceles. Isosceles, there we go. So, proven that those are isosceles. Now the final thing, showing this connection. Therefore, so we're going to say this is equal to this. ME equals CE, and CE equals NE, thus ME equals NE. Since, just restating, since E is the point where CD and MN intersect, this way we have proven that CD bisects MN since it's split it into two equal lines. QED. And if anyone doesn't know what QED means, it means quod era demonstrandum, just a Latin thing people do. It just means which was to be demonstrated. And this was what was to be demonstrated. CD bisects MN, right up here. Anyway, thank you for watching this video. Keep on problem solving.